Good day, everyone. My name is John Russell Esmanlupig from Davao Oriental State University, and I'm gonna solve some problems in a topic called logical equivalences. Logical equivalences is a topic, the relationship between two statements that both have the same truth values. From the word itself, equivalences, so these both values have the same equivalent. So the topic is quite confusing, but it can be identified its solution using your critical thinking and use the propositional logical sense of your mind. So yeah, so I'm gonna solve some problems here. So this propositional statement instruct us that it must be concluded in a tautology statement. So tautology means uh, tautology is a propositional statement that all truth values are true. So this statement is already is somehow called is somehow a tautology, but I'm gonna express this using truth tables if this statement is a tautology. So the statement is P amplifies Q to the conjunction to the Q amplifies R that amplifies P to amplifies R. I don't understand how I pronounce this in the English sentence, but you get the point. So I'll be using 1, 2, 3, 4, 5, 6, 7. So I'll be using 9 tables or suppose or 8. Yes, I'm gonna use 8 tables. So I'm gonna insert some table here. Then lastly is this one. Wait. So these are the 1, 2, 3, 4, 5, 6, 7, 8. So these are 8 constant values since I extract the the first tautology statement. So I'm gonna put the constant values of these three. So I'm gonna put T, okay, T, F. Next is its constant. T, oh, P amplifies Q. So so I'm gonna P amplifies Q. So T amplifies T equals T. Then and P amplifies Q. So the same. Then P amplifies the same. So I'm gonna imply this P to the Q state. So F F T T F F T. Then T F and F is the same since both have the same value. So T and T. Next is Q R, the same concept pa rin. So Q to R. So T F T F T T T F F F. So yeah, so P T, P, R, T, wait, T, 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 L, T, F, T, 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 F, T, 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 R. Wait, it's T since, yeah, T, T, T. Yes, so yeah. Next is PQ conjuncts to P and PQ to conjunction to QR. So I'm gonna follow PQ to QR. So T T T R T T right, F T T Q R F T T T T F T T F T F F. Lastly is this one amplifies to PR. So T T T T T T T T. So you can see the first statement is actually a tautology since the final answer is all of the truth values are true. So yeah, let's proceed to number two. So I'm gonna proceed now. Number two. So number one is already get the tautology statements about these are are answered. So logically, this statement is a tautology statement. So let's proceed to number two. So one, two, three, four. I'm gonna build also eight tables or nine, since they have two brackets as well. So maybe I count this as also a three tables and also a three statements and also two. I'm gonna insert. So there are total of nine constant values here. So I'm extracting this statement into this, and yeah, first I'm gonna center this. So I will put the constant value T T T F F F and F. Mm, T T F F T T F T F T F. So P this junction Q. So T T T and then and T P then F and F. Since since it have the same value but it is an F, so it all equals to F as well. So next is P amplifies R. So P amplifies R, so the truth value of P will automatically exchange its state to letter R. So wait, T F T F T T T F T T T and T. Uh, T, 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 T. So yeah, correct. Wait. So it amplifies P to letter R. Next is Q amplifies R. So T, F, T, 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 F, T, F. I wait. T. So T, T, F, T, 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 F, T, F, F. So next is P conjunction Q. P disjunction Q conjunctions conjuncted to P amplifies R. So I'm gonna follow P disjunction Q to P amplifies R. So uh, P Q conjunction T uh, T T T wait T F T T T F T T TF 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 Ay, wait F. So TF TTTF TF oh PR so confusing. Wait T T T F T F T F so T F T F T this is T and then F T T F T F T. So correct. Next is wait what bracket here. So this conjuncted to Q and R. So I'm gonna follow this. So T conjunctions to T equals T and then conjunction P P V Q Q R. I can't see anything here. So let pick. Oh, okay. F E Y E F T T F F F T F T F F F F. So T F yes here. Lastly is these three this constant value will amplifies to letter R. So amplifies to R. So T T T T T T T T F T F T amplifies T F T then T. So as you can see, the truth this statement is a tautology statement. So as you can see, the final answer is all both values are true. So yeah. So this constant value amplifies the letter R. So T and T T and F and F so equals to T and T equals to T, F and F, T and T. So F implies F, also F implies T, which is T, and F equals T. So let's proceed to number 2. The letter B, which is stating De Morgan's law into English sentences. Let's proceed to letter B. So letter B instruction is use De Morgan's law to find the negation of each of the following statements. So first statement is John is rich and happy. So let's find out its De Morgan's law. So first let us represent this statement into these variables or state constant values. So let John is rich is letter P. So P and the conjunct and the connector end is a conjunction. So gonna copy conjunction here. So here is so conjunction and let happy letter Q. So this is the it's not negation value. So let's transfer it to non-negation value. So the equivalent of this is is answer shift P and then which is equal to this. So the conversion of this statement is uh, negation 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 P disjunction to negative negation Q. So it which means that the equivalent of this is negation P conjunctions to disjunction to negative Q. So the negation of this statement is John is not rich and not wait, which is disjunction or not happy. So that is the negation of this statement. So next is Carlos will ride a bicycle or run tomorrow. So next letter will be R. So let Carlos will ride a bicycle, and then since the connector of the sentence is or, so this is a disjunction, and then run tomorrow let run tomorrow letter S, which is the first De Morgan's law shift then R vs which is equals to negative R negative R negation R disjunction negative S negative S negation S sorry very common to negate negative and negation is very similar which I am very sorry. So that is the wait conjunction conjunction um conjunction wait conjunction conjunction S since the negation of disjunction is conjunction, right? So yeah, so that is the total of that is the Morgan's law of the statement, which is negation of it is um wait, honey, uh, negation of it is Carlos will not ride a bicycle and and not Carlos will ride a bicycle and not run tomorrow. So that is the Morgan negation statement using the Morgan's law formulation. So let's proceed to the last part of the problems. So the letter C. So I woke up in the early morning to get this video. So I'm gonna solve this right now. So this is my answer in showing a logical equivalence if both statements are equivalent by using first truth table. So let's find out. So I'm instructing this statement into seven variables. So PQ is are very common constant values, so they are included here. And also its negation, negative P, negative Q. And also its constant of P by conditional Q. So here is, and its uh, and also this one, the negation P by conditional Q, and its opposite P by conditional negative Q. So getting the if both of these are equivalent, we're gonna use truth table. So first is constant values. Value of P is ETFF. So they are this is a very constant variable. So Q is TF. Next is the negation of P is FFET. Next is negative negation Q, FTFT. So they are more like opposite. So next is P by conditional Q. So if you translate it into English sentence, it is the connector word of if and only if. So P by conditional Q. So if both of these are true, so they are actually true. So and next is P, T, and F. So they are not the same value, so it is equal to F. Next is it is the same. Ft equals to F, and F and F is equal to T because the word because by conditional states that if and only if. So it could be true or not. So they are both false, so it could be true. So yeah, so they it is equal to T. Next is the negation P by conditional Q. So I'll follow this one. Negation P by conditional Q. Where is the Q? Here. So FT, so F and T, so equals to F and F equals to T and T equals to T, and F and T and F equals to F. So the final answer of the first part is FTTF. Next is P by conditional negative Q. So P negation by conditional of negation Q is P negation Q. So T and F equals to F, T and T equals to T, F and F equals to T, let's see F and T equals to F. As you can see, this both um, propositional variables are equivalent. As you can see, they are both the same result of true variables and false variables. You can see FTTF and also FTTF. So this is the first part by getting its equivalent. So we can so in this part we can really say that it is logically equivalent, but this is not this is the first part. Yeah, so next is using logical equivalences laws. So let's proceed. So next step in making if both if both these statements are equivalent by using logic equivalences laws. So first we use truth tables, so we actually made it so they are actually equivalent. Next is using equivalent law. So I'm just putting image here to to get a more like a copy for me to understand what are the logical equivalences since this problem is biconditional. So I'm gonna start solving right now. So this is the result in uh, using logical equivalences laws. So since the truth table, the result of truth table is this one. It is not tautology and it is called contingency. So which means the result either false or true. So the result is false and true. So it is a contingency result. So I've been using the contingency key in using logical equivalences laws. So first is I'm extracting this one into I'm being, following the logical equivalences in biconditional table. So this is the biconditional table, and this is first one part in dealing with biconditional statements. So I'm instructing this since it has negation part. So I put the also negation here since it helps to understand and following the steps in calculating this part. Next is the first De Morgan's law. So since as you can see, I did the it distributed the negation. As you can see, it has negation here. This part it has no negation. Next is Q, and then the conjunction into this disjunction. Q and amplifies P. So that is my opinion to into my next step. Next is following logical equivalences and conditional tables. So this is one. So I'm converting this part into this one. As you can see here, it will turn into negative. The result is negative p. What's this? Disjunction q. As you can see here. So I put also this one part q disjunction p as also. So yeah, that's it. So next is De Morgan's law and double negation law. Since I'm using the double negation law since the before part is have double negation symbol, so I will multiply it into 0. So multiplying this part will it turn into 0 or no negation. So as you can see here, p uh, negation times negation equals to 0. Negation, so negation times disjunction equals to conjunction, and so on and so forth. You can see here, it will turn into opposite sides, disjunction into conjunction symbols, and the negation is actually transferring it to specific place. So P equals to negation P, just like that. Next is I'm using distributive law since it helps me to find the logic. It's to find the last part of the provision what's this equivalences laws to find it. So I'm distributed the this one. So the this it I extract it. So this is the total. It is very long. So as you can see, I extract this one into this one, then this one into this one. So I distributed here into two parts. So next is cumulative law and negation law. As you can see here, why I use cumulative law, because both this when you calculate this into truth table, it will equals to true. So this one is true, and this one also it is true. So when you calculate it, it will equals to two, truth. So yeah, and also using the negation law. So I put negation here. Uh, you can see here, just like that. So as you can see here, this part here will turn into truth table, true, like letter T here. So the next step is I'm using the identity law. So identity law means this one. If P if P conjunction T, it will automatically equals to letter P. So as you can see here, there's no T in this part, so it will become identity, it will become result, it will result into this. So there's no here, there's no letter T here since I've been using identity law. So to identify where the truth table is there, so it will vanish here. Next is cumulative law. So I've been using cumulative law twice because it helps me to find the because the law helps to interchange the variables. So as you can see here, it interchanges the variable. So yeah, negative p v negative negation q. As you can see here, it interchanged the variable. So I interchange it again. So it will enter it turns into this one. So I use cumulative law twice to interchange twice. So next is using the logical equivalence law in conditional table and double negation law. As you can see here, this part, is equivalent to negative p, uh, like this, disjunction q. As you can see here, and double negation law. As you can see here, negative q, negative q here, which are very the same. So you can see here, in both, I've been using the logical equivalence law in conditional table since this part is equivalent to this part, which I calculated it is very the same. So this is the result, and using the double negation law, since the last that since the this one is it is negation. So I'll put negation into it to find its equivalent. So as you can see here, and then using the double negation law, it will result into this. So that is the result. So this is therefore, therefore, uh, negation P, negation P is logically equivalent to P implies negation Q. So that is my answer. I hope you understand. Since I also follow the logical equivalence involving biconditional statements, as you can see in the last part, they are actually very the same, but it has parentheses here. But if you calculate this into truth table, they are different. Always remember they are different. But so so the question here is to find this equivalence. So I think this is the right answer according to my critical thinking, also the logical professional sense of my mind. So that's it, guys. So hope you learn a lesson. Uh, Again, I'm John Rasa Manlupig. I see you guys next time. Bye.